Hello friends, welcome to new session. This is session 8 on projection of plane surfaces. Again we'll start from the top view, hence we generalize this under top view starting problems. Okay, here you see this, please understand we are doing hexagonal lamina. So far in the earlier session, when it is edge on HB, what are the variations and all that, what could be done for projection, we've done. Now here, for hexagonal lamina, if they say corner on HP, previous position you can't do. You have to change the position itself, and that position I'm just explaining now. Please follow here. Now see here, XY line. Okay. Above this is vertical plane. Okay, vertical plane you can clearly see. This is horizontal plane. Can you follow? Horizontal plane. This is hexagonal lamina. Now the observer is looking from here to get the front view. Observer is looking from here to get the top view. Okay. Now when you change the position in this way, okay, when you're looking from here, left corner is A dash. This is B bracket F, B dash bracket F dash. This is C dash bracket E dash. This is D dash. Okay. C can be seen, E cannot be seen, B can be seen, F cannot be seen. It is B dash, F dash, C dash, E dash, and D dash. Now you see here. This is how you see. This is the top view. This is the front view. When you tilt, when you lift this up, okay, this VP, no, when you lift this up, it is corner on HP with surface inclined at some degrees to HP. Okay, it may be 30 degree, 40 degree, 50, whatever may be the problem given, you just do. Even otherwise, keeping D constant, that is, if you lift A dash, it is still corner D on HP. Did you follow? Here, I have lifted this from D dash. I have lifted here so that corner A is on HP. If you lift here, it will be corner D on HP. That means whether you lift this way or this way, whether you lift D up or whether lift A up, it is corner only on HP. That is why this position itself is called corner position of hexagonal lamina. Please understand, this gets later on converted into hexagonal pyramid, hexagonal prism, and all that in solids. When they say hexagonal pyramid or hexagonal prism has a corner on HP, immediately take it to this position only. When they say edge on HP, okay, hexagonal pyramid or hexagonal prism, edge on HP, you take it to the previous position what I have told you in earlier sessions. Okay, now I think this is clear. This is XY line. This is VP HP. If you see here, I've drawn the true surface. I've started from top view. That's why you call it as top view starting problems. Okay, I've started here. A, B, C, D, E, F. I've written the front view here. Then I've lifted up so that this is anyway, it is attached to VP. Okay, what you see in the front view is AD length, that is diagonal AD length. Okay, when you move it parallel to VP only, that is attached to VP only, the same length can be seen. This front view length and this front view length will remain same, 30 degree. Okay, this is surface inclined at 30 degree or diagonal AD inclined at 30 degrees to HP. See here, please understand again, I have been repeating this here afterwards. Okay, in all the problems, even after that is in engineering problems, later on in your engineering, post-engineering career also, what they give is one XY line and all that won't be there. Okay, one line, if for an imaginary line, whatever you have above, for first angle projection, I'm telling you, for first angle, whatever you have above is the front view, whatever you have below is the top view. Now it is XY. Now at least here, we'll draw XY line VP HP. Whatever you have in VP is the front view, whatever you have on HP is the top view. Okay, this is the way you should understand. See here. Now, use here, hexagonal lamina of sides 25 has a corner on HP. Immediately be careful. Hexagonal lamina, when you write, don't take edge position. It has to be on corner position. And rotate it about this corner till the diagonal content in this corner is inclined at 45 degrees to HP. And the top view of the diagonal content in the corner is inclined at 30 degrees to VP. Draw projections. Okay. Now you see here. First, importantly, see here. Change the position of hexagonal lamina. This is corner position. Don't take edge position like the way I was doing in the earlier session. Okay, this is AF, This is AB all 25. Okay. If you do this, this is AF. No, this is totally 120 degrees the angle. AF 25 plus 20, 60 degree. This is 25 minus 60 degree. If you are doing it in solid edge or some software, this is FA horizontal line 25. This is horizontal line 25. Then this will be ED. Okay, 25 minus 60. This is 25 plus 60. In that way, you can complete. Okay, a demo problem will be there after that. You can know how exactly these things have been done in solid edge. Okay, XY line, VPHP. This is what I said in the previous thing I have shown you. Once I draw XY, VPHP, whatever above XY line you have, that is the front view. Whatever below XY line, what I have is the top view. Okay. Now, what you're seeing in the front view is AD. Can you imagine? AD is a diagonal for this hexagonal lamina. This AD is parallel to VP. As a result, A dash D dash is in true length. Okay. A dash D dash is in true length. Okay. Now, if I do this way, okay, this front view and this front view are the same because even after moving, this AD will still be parallel to VP only. Okay, parallel to VP. That's why first stage front view, second stage front view take same. Now the problem is corner on HP, corner A and HP, which surface inclined at 45 degrees to HP, are same diagonal AD inclined at 45 degrees to HP, both are same. Okay. Now if you take the top view now, you take the top view. Okay, you are looking from here. Get all the points. Okay, A and D on this. This is B and C. This is F and E and all that. If you see here, you should know here at this stage onwards, when you look to this, here, this is top view starting problems now. All this is in true length. Complete thing is in true length. We started from top view. That is why we say it's a top view starting problem, sir. Okay. Then you got the front view. When this lamina is inclined at 45 degrees to HP, and here corner on HP, don't you think all have lost true lengths? A, B, B, C, C, D, D, E, E, F, F, A, nothing is in true length. That you should know. Here afterwards, oh, which is in true length, which is not in true length, those things you should know clearly. Okay, nothing is in true length here. Okay, now what we are doing now here is, this is surface inclined at 45 degrees to HP, I got the top view. Keeping the inclination constant 45 degree, and if I rotate, that means it is pivoted at A, okay, because it is A on HP. If you rotate, whatever you do, as long as inclination of 45 degrees to HP is constant, top view won't change. You can make it to any position. Now what I'll do is, this top view, the diagonal contains the corner AD, I've inclined at 30 degrees to VP. Okay, a simple problem. Take the same top view, move, copy, paste and rotate in such a way that AD is inclined at 30 degrees to VP. 30 degrees to VP you do. That means this top view and this top view say, you make it at 30 degree. That means once you do this, take the projectors up. Okay. And on this D you should get, on this C and D you should get, on this you should get B and F, on this you should get A. In that way, if you join, you get the front view. You get the front view. Please follow. The front view is this. This front view is for what? Corner on HP. Surface inclined at 45 degrees to HP. And with corner on HP, surface inclined at 45 degrees to HP, I'll rotate the top view. This top view, that means the lamina, I'll rotate. When the lamina is rotated, okay, with a constant inclination of 45 degrees to HP, the top view does not change. I rotated in such a way that pivoting at A, that is, A is on HP, pivoting at A with a constant inclination of 45 degree, I'll go on rotating till the top view. This is not the true length. Please mind that ADA diagonal is not in true length. That is why in the problem they are given, the top view, the diagonal contain the corner is inclined at 30 degrees to VP. You incline it at 30 degrees to VP and get the projections. That means this position, if you know clearly, it is corner on HP, surface inclined at 45 degrees to HP, okay, surface or diagonal inclined at 45 degrees to HP, and the top view of the diagonal contained in the corner inclined at 30 degrees to VP. In this complex position, when you see from the front, how it appears has to be drawn. This is how it appears, okay, in the front view, and this is the top view of this. This is one problem, one very good problem from the examination point of view. Okay. This is that is problem 42 from Vishweshwara Technological University textbook, that is primer. Okay. Now, see here another problem. Hexagonal lamina of size 25 has a corner on HP and rotated about this corner till the surface of this lamina is inclined at 45 degrees to HP and the opposite corner touching VP and the lamina perpendicular to RPP and all that. Or the diagonal contain the corner HP parallel to RPP. Okay, these things, see here, hexagonal lamina, corner on HP. Immediately take the corner position and rotate it about this corner till the surface is inclined at 45. So what, that is almost same as previous problem. But here opposite corner is touching VP, that I'll tell you. Okay. See here, up till here it is same as the previous problem. XY line, VP HP, A B C D E F, A dash, B can be seen, F cannot be seen, B dash, F dash. When an observer is looking from here, C can be seen, E cannot be, C dash, E dash, D dash. And okay, this is surface inclined at 45 degrees to HP or diagonal inclined at 45 degrees to HP. For this, you got the top view. Up till here, it is same as the previous problem. In the previous problem, what I've done is, the top view of the diagonal contained the corner was inclined at some degrees to VP. Now, what they said is, corner on HP, opposite corner on the diagonal, that is D. Okay, corner A is on HP. Opposite corner on the same diagonal is D. That is touching VP, they say. Okay, and this diagonal is parallel to profile plane means for an imaginary line here, okay, x1, y1, RPP will be here. AD is parallel to profile plane. That you should understand. Always when I write x1, y1 here, if you imagine x1, y1 here, RPP will come here. For an x1, y1 line, if this is parallel, no, if this is parallel to the profile plane, you can say, and in parallel to profile plane, and also you can later on say that the lamina will be perpendicular to RPP also. Okay, anyway, now the problem is corner on HP with surface or diagonal inclined at 45 degrees to HP. You got this. Keeping inclination constant. Okay, I'll inclination 45 degree constant. I'll rotate it in such a way that rotate and move in such a way that it is the D will be on XY line. That means corner A is on HP, opposite corner on the same diagonal D is on VP. Okay. Once this is done, take the projectors up. D should be on this, C and D, B and F, A on that. In that way, you get the front view. Okay. Once you get the front view, okay, you can clearly say A dash on XY line means blindly say A is on HP. D is on XY line means it's not D dash. D should be on VP. But what is the connection between A and D? A is a corner which is on HP. D is opposite corner. In that way you say A is on HP. Opposite corner on the same diagonal is touching VP. Okay. This is how the problem, even this complex problem has been simplified in a simple way. Okay. Now as you see here, what you should always remember here is, when you draw this XY line, VP, HP and all that, looking at the problem itself, you should be in a position to define the problem yourself. It has hexagonal lamina 25, corner on HP with diagonal or surface inclined at 45 degrees to HP, and corner on HP is A. And what you've done is opposite corner on the same diagonal touching VP. That means D is on XY line. That means you yourself can say, that means corner on HP, opposite corner on the same diagonal is touching VP, and the lamina perpendicular to RPP you can say, because if you draw x1, y1 and draw this side view, you get only D dash, E double dash, bracket C double dash, F double dash, bracket B double dash, A double dash. It's a straight line. It will be seen as a line in the side view. You can say it is perpendicular to RPP also, or this diagonal is parallel to profile plane. Okay, these things you can say. I keep repeating. Okay. Now anyway, the problem gets over at this stage, and this is end of session 8. We'll continue in session 9. Thank you very much for watching. Thank you.